Standard error of the mean. If the standard deviation of a normally distributed population is 22, and we take a sample of size 4, then the standard error of the mean is. This formula is also on your formula sheet. On your formula sheet, it's written as sigma x bar equals sigma divided by the square root of n. That's the formula for the standard error of the mean. That's it. So we're given sigma, the standard deviation is 22, and the sample size is 4. Let's just plug it in and see what we get. The standard deviation is 22 divided by the square root of 4. That's 22 divided by 2. Standard error of the mean is 11. That's it. I know you're surprised. That's it. 56. In order to have the standard error of the mean equals sigma over the square root of n. In order to have that, right? In order to have that equal 10, we need to take n samples, I don't know how many, from a normally distributed population with standard deviation of 20. So they give us the standard error this time. They give us the standard deviation, and they want us to find what n has to be in order to make that work. So let's solve this. Let's cross multiply. 10 times the square root of n equals 20. Divide both sides by 10. So the square root of n equals 2. If I square both sides of this equation, square root and square, the inverse operations, they cancel. So n equals 4. Sample size needs to be 4. We need to take 4 samples, rather, from this normally distributed population. Sorry for saying that incorrectly. Okay. 57. Whoops. The standard deviation of a normal distribution is 20. What is the standard error of the mean obtained by averaging 225 samples? That's my n. So we want the standard error of the mean. That's sigma divided by the square root of n. Standard error of the mean is 20 divided by the square root of 225, right? Which is 20 divided by 15, which is 1 1/3, so 1.33 repeating. That's your standard error of the mean.